Regular expressions make removing characters from a string incredibly easy. First, let's import the regular expressions module. It comes built in with Python's standard library. No extra installation is needed. This module is called Re, which simply stands for regular expressions. Here, we have our target variable. It contains a sequence of letters. Let's say we want to strip out all characters from A to C. This is where Regex truly shines. We will use the powerful sub function. This function returns a brand new string by replacing every leftmost non-overlapping match it finds. Let's see how this works in action. We pass our original string right here as the third argument of the function. The first argument defines the pattern we want to target. For this example, we are targeting A through C. We can do this in a few ways. Let's try this first. We'll replace those characters with an empty string, effectively deleting them. Let's run this and see the magic. Notice how A, B, and C completely vanish, leaving us only with D, E, F, Q, X, Y, and Z. The A to C range is clean gone. Alternatively, we could write it like this. Explicitly typing out A, B, C, running this achieves the exact same result. If you only want to remove A and B, just remove the C from the pattern. Now C is preserved along with the rest of the string. Using a dash to specify a range like A to C is incredibly efficient. You don't have to manually type every single letter. Python's Regex engine already understands alphabetical order. It knows the alphabet perfectly. So while you could explicitly state your target letters, using ranges saves you massive amounts of time. Imagine wanting to clear out everything from, say, A to Z. Typing out 26 characters manually would be exhausting. But with A to Z, you instantly reduce it to an empty string. If we change it from A to Y, you'll see that only the letter Z remains untouched. It's kept perfectly safe because Z falls outside our range. Of course, we could go overboard and type out A, B, C, D, E, F, G individually, like this. But as you can imagine, trying to map out every single letter gets tedious very quickly. That is exactly why utilizing dashes is a lifesaver. Now for a brilliant bonus tip. Let's reset to A to C. Great. What if you want to remove the range A to C plus the letter Z? Simply append Z directly to the end of your pattern, and it's gone. That matches A to C plus Z. You can combine ranges too, for instance, adding Y to Z directly alongside it. You might be tempted to separate them with a comma, but beware, Regex will see that comma as a character to remove too. By leaving it out, any actual commas are kept perfectly intact, while successfully removing A to C and Y to Z. Remember, as soon as you use a dash, Python expects a valid character range. Let's dive into the history of the new line character across Windows, Mac, Linux, and Unix, and see why it's so vital in Python. Mastering this now will save you from major debugging headaches later. You've probably seen these hidden escape sequences, \n and its partner, \r. Early on, Linux developers made a definitive decision to use a single character for line breaks. That's \n. Modern Mac OS does the exact same thing because it's built on a Unix-based architecture, but Windows has always used both \r and \n together. To see why, think of an old typewriter. Imagine typing out a sentence like, "Hello, John." "Hello, John?" Once that's written, pressing the Enter key drops you down to a fresh line. But it also resets the cursor right to the beginning so you can start typing your next line instantly. It doesn't just leave your cursor hanging mid-air. Directly under the last letter, Windows handles this sequentially. \r returns the cursor to the left, and \n drops it down to the next line. But Linux and modern Mac OS systems realized, hey, we don't need two separate characters. They handle both actions natively with just one escape character, \n. So Windows explicitly demands both steps to reset and move down, while Linux and Mac keep it unified. This means Windows files store two hidden characters for every line break, while Linux and Mac files will strictly show \n. Let's prove this right now with a real file. Here is an example file on Windows containing Hello World. Simple and straightforward. Watch what happens when we open and read this file using Python's binary mode. Look closely at the output. Windows has explicitly added both \r and \n. But here's where Python works its absolute magic. By default, Python automatically converts that pair into just a single \n. This ensures seamless cross-platform compatibility across all operating systems. When you read a file in standard text mode rather than binary mode, Python handles the translation completely in the background, swapping it out for a clean \n. Notice I'm using the built-in representation function, REPR, which unmasks any hidden characters in the text. If we use a standard print function instead, those hidden symbols disappear and the text formats flawlessly. Newline characters are critical in Python and operating systems. Mastering how they work will accelerate your coding journey. Check this out. Here is an example text file. Inside this file, you can see the words hello and world. They sit on separate lines, separated by a hidden new line. When Python reads this file, we can tell it to keep the original new lines exactly as they are. Since we are running on Windows, those new lines look a bit different. They use a \r and a \n. This layout is actually historic. The R tells the cursor to return to the start. Imagine typing the word hello right here. Once your cursor hits the end, how do you jump to the next line? Watch this. To begin a fresh line, Windows performs a two-step process. First, \r resets the position, straight back to the beginning of the line. Then \n drops it down to the very next line. Without that carriage return, the text wouldn't reset properly. It would just drop straight down, without going back to the start. But here is the real mystery. Why does Python show two backslashes? Let's extract and print the raw data from our text file. We are keeping the new lines exactly as the operating system intended, which is Windows formatting. When we print it, the formatting executes, outputting hello world. The new line is working, but it remains invisible. But if we use the repair function to inspect the raw data, look at that. It displays \r and \n. Remember, Windows natively uses just one of each, just a single \r and a single \n, so why is Python doubling them up? Because it evaluates this as a string within a string. Python is escaping those special characters to stop them from triggering. It wants to show you the actual literal text instead of executing the line breaks. That is the power of character escaping. Now, what happens if we print this exact representation? Let's wrap the entire expression inside a standard print function. Let's execute it and look at the result. It smoothly displays exactly one \r and one \n, perfectly matching Windows. Always use the print function to get the true, clean output. When you're working inside interactive Python, it behaves dynamically. It automatically escapes special characters for visibility. And that is all there is to it. Interactive Python handles the heavy lifting, printing the evaluation automatically. It outputs the final expression instantly, but when we explicitly add print, that behavior changes. It executes the print function cleanly, formatting the output flawlessly without the extra backslashes. Mystery solved. Now you know exactly why Python uses double backslashes. Let's see how Python effortlessly handles new line characters on Windows and other operating systems. I'm running this on Windows, and here is our example text file. It simply contains hello and world. There's a hidden new line here because I pressed the Enter key right after the first word. That inserts a new line character. Watch what happens when we read this in binary mode. Notice that inside the open function, we use the RB parameter for reading binary. Let's look at what these parameters actually mean. R stands for read mode, which is the default. B triggers the binary mode. We could explicitly pass T for text mode, but we can skip it since it's already default. Let's execute this using binary mode. Once executed, look at the fascinating output we get. This reveals exactly how Windows handles new lines. It prints hello, followed by \r and \n. On Windows, it always adds both \r and \n. Other systems only use \n, ignoring \r entirely. So, how does Python handle this automatically? If you don't supply a specific mode and just open a file, let's see what happens behind the scenes. It prints the text normally as hello and world with a clean line break between them. But let's look at the raw representation using default mode. Remember, we didn't pass any extra parameters this time. We completely omitted them. By default, Python opened it in read mode and automatically selected standard text mode. When it does this, it cleverly replaces Windows-style new lines. It takes those \r and \n sequences, which are the two standard characters Windows uses, and transforms them seamlessly under the hood. Because we aren't using raw binary mode, Python converts that pair into a single \n. Why? Because Python prefers a single uniform newline character. This matches how Linux, Unix, and modern Mac OS work. Fun fact, older Mac systems used only \r, but they later migrated over to \n. Today, modern Mac OS strictly relies on \n. That's a quick bit of history for you. But watch how beautifully Python standardizes this. Python simply adopts \n as its standard. Even though Windows still clings to \r and \n, Python ensures cross-platform compatibility by default, translating Windows new lines into a single \n. This is why your string representations look so clean. So, what if you want to replace a new line in your code? Once the file is loaded, you don't need to worry about \rn. You can target a single \n directly. Let's perform a quick text replacement right here. We'll use the regular expression module. Just import it directly. We write our import statement here, import re. Then we simply replace the \n character with a space. And look at that, we get a clean hello world. You see, you don't need to explicitly match \r. No need for that. It's redundant. You could use a question mark if optional, and that will still work perfectly. But overall, Python keeps it incredibly simple. Just use \n to swap out any newline character. As we dive deeper into Python regular expressions, it's essential to master two critical characters, the tab and the newline. Let's start with the newline character. Take a look at this string right here. Hello, new world. Got it? When we print this, watch what happens. The output reads hello space new and then world on a fresh line. Notice how world is shifted down. That's because our code utilizes triple quotation marks. This unlocks multi-line inputs in Python. Hit enter in the editor, and a new line instantly appears in your output. Behind the scenes, Python stores actual new line characters. But where exactly are these hidden characters? If we inspect the raw formatting right here, you'll spot a clear new line character immediately following the word new. Right there. And another one right after, creating that empty line. Let's move new onto its own line to make this crystal clear. Let's clean up this extra space. Now we have hello, followed by a new line character written as \n. Then comes the word new, instantly followed by another new line, and finally the word world. Hello, new world. Here is the trick. You don't even need triple quotes to do this. You can embed these new line characters directly into a standard single line string. If we run a basic single line string without them, everything prints on one line, but to split it up, simply insert the \n escape sequence, and look at that, hello, new, world. Break perfectly across separate lines. The raw representation matches exactly what we typed, proving we don't need triple quotes. Now, how do we manipulate this with regular expressions? If we have a string containing new lines, we can easily replace them using the subfunction from the re module. No external installations needed. It's built right into Python. We will target the new line character and swap it out for an empty string. Run this and boom, hello world is unified on a single line. Without that powerful regex replacement, it defaults back to multi-line layout. But regex gives you full control. The exact same magic applies to tabs. Let's swap out that new line character for a tab. Check out this shift in the output. There is a wide gap between hello and new. That is a tab character. It behaves completely differently from a standard space. If we manual input spaces like this, adding 1, 2, 3 spaces, they register as 3 distinct highlightable slots. But look closely at \t right here. That entire block is a single unified character. In our raw output, it is explicitly shown as \t, while new lines show up as \n. This is the foundation of mastering \t and \n. Remember, T stands for tab, and N stands for new line. Let's see how regular expressions can effortlessly replace them. We can target them precisely. Watch how we swap a tab. If our string contains a \t before new, the regex detects it and cleanly replaces it. Without the regex, that wide tab space stays put. But to swap it, we simply target \t and replace it with an @ symbol. Just like that, the replacement is live in the output. Now you fully grasp how tabs and new lines function inside Python's regular expressions, giving you total power to manipulate text. The Caret character in Python regex wears many hats, but today, let's unlock its primary power. First, we import the standard regex module. Next, here's the target string that we want to search through. Our ultimate goal is to only trigger a match if the string begins with INV. Since it does, we simply place the caret symbol right at the very beginning. This means Python will strictly look for a match only when INV leads the entire string. But check out this example. INV is completely missing from the start. So when we run this piece of code, it hands us a none value back, which represents null in Python. We failed to get a match because of that strict anchor. Watch this. If I remove the caret symbol from the pattern, boom, we instantly score a successful match. This time, the match is found starting way over at position 6. Counting index 1, 2, 3, 4, 5, and landing right there at position 6. But add the caret back like this, it forcefully demands that the match exists at the absolute beginning. This includes easily missed traps, like a sneaky leading space character. Spaces break our expected start. To succeed, it must cleanly start with INV. That is the power of the caret anchor. But wait, what if you need to find a literal caret symbol in your text? There is a caret symbol here. If we want to include it in our search, we need to deploy a backslash. Let's see what happens if we omit it. As you can see, our code fails to find a match. It searches for INV at the start, but fails because it is not there. Instead, our target string begins with that literal caret symbol. To track down that specific character right at the very beginning, watch this. Even if we add a leading space, it can still track it down. Even with that unexpected leading space setting things off course, to target that exact literal character, you need to pair it with another caret. This setup instructs Python to look for a literal caret at the start. Remember, use that escaping backslash to neutralize the character. Do that, and it will effortlessly find a match. Now, if you expand your pattern and want to keep searching for it, make absolutely sure you include the caret token right over here, and it works beautifully as expected. Let's strip away that space and check our code. It starts perfectly with the caret followed by INV. Broadly speaking, the caret is your go-to anchor to lock down a very specific text pattern. By matching at the beginning, just like we did for INV, it locates it seamlessly every single time. Struggling to master regular expression syntax? Then this quick guide is for you. In Python, we import the regular expression module. It's simply called RE. Hovering over it confirms built-in regex support. A truly powerful feature in Python. Let's look at a practical example. We have the string A, B, C, 1, 2, 3, along with an exclamation mark. Watch carefully. Look here at the digits and the exclamation point. We want to replace everything except A, B, and C. To do this, use the caret symbol inside character classes. Let's see it in action. We are calling the sub function from the RE module. The updated string will be saved in a new variable. For our pattern, we will target a specific set of characters and replace them with an empty string. Here is where the caret comes in. What does it do? The caret symbol inverts the match, acting as a not operator. Instead of matching A to Z, it targets everything else. This means our substitution function will swap non-matching characters with a blank space. Effectively, we remove everything that is not A to Z. The caret completely flips the logic to not. If we run it without the caret, notice the difference. It removes all letters from A to Z, stripping away A, B, and C, leaving only the numbers 1, 2, 3, and the exclamation mark. Now, let's put the caret symbol back in. Adding it back, watch how it protects the letters and removes everything else. It completely deletes any character outside of A to Z. Right? The caret means not. The digits and exclamation mark are not letters, so they get instantly removed, leaving us with a clean letter-only string. This is incredibly useful for cleaning phone numbers. Often you receive messy data with dashes, like a formatted phone number. To extract pure digits, just remove anything that is not 0 to 9. And there you go, a perfectly clean phone number. Save this trick, bookmark it. It completely unlocks the power of regex. It allows you to transform raw text from a messy string format packed with extra words and dashes straight into pure digits. Python makes it incredibly simple. If you found this helpful, smash that like button and follow for more. Drop a comment below to help support the channel. Now, the caret symbol has a second meaning. When used outside of square brackets, its function changes completely, as we've seen before. It anchors your search to the start of a line. The target string must start with that exact pattern. Here, we place the caret symbol up front. In this case, capital INV. The letters INV. Your string must start with them. Otherwise, it won't find a match. Notice that INV is in the middle here, not at the start. As a result, there is no match. It returns null. simply because it doesn't start with INV. Remember these two distinct meanings. Outside of square brackets, it anchors to the start. Inside square brackets, it completely changes into a negation tool, matching anything that is not A to Z. When combined with a replacement function, like Python's submethod, it instantly strips away everything except the letters. Today, we are unlocking the power of email validation using regular expressions in Python. First, let's import the built-in regular expression module, known as RE. It comes pre-installed with Python, giving you instant regex pattern matching tools. Take a look at this test email, jamessmith@example.com. Let's run the code right now to check the output. It returns true. That means our pattern is a perfect match. Let's break down how this syntax works. We start with this caret symbol, which asserts that the string must begin right here. The allowed characters live inside these square brackets. They can be letters from A to Z. No commas are needed inside the brackets. Just list your letters, numbers, and symbols. This dash defines the character range. Instead of a tedious setup like writing out every single letter manually from lowercase a, b, c all the way to z, regex gives us a brilliant shortcut. You simply write lowercase a to z like this. To make it completely case insensitive, we include uppercase a to z as well. Now both cases are fully accepted. Next, we add 0 to 9 for numbers. We can also include special characters like a literal dot, underscores, percent signs, plus signs, and hyphens. This defines what the username can contain. This trailing plus sign means one or more. We need one or more of these characters to appear right before the mandatory @ symbol. Notice the @ symbol is outside the brackets, meaning its presence is strictly required. It must follow the username characters perfectly. Now, let's look at what comes right after the @ symbol. Here, the domain prefix can contain lowercase letters, uppercase letters, numbers from 0 to 9, dots, and hyphens. Once again, this entire set must match one or more times for the domain name. Think of a domain like example.com. The example part is covered. Next, we must match the literal dot before the extension. In regular expressions, a standalone dot actually means any character. To fix this, we use a backslash to escape it, creating a literal dot. A real dot is required. After the dot, we look for domain extensions using letters from A to Z, in either case. No numbers allowed here, since standard extensions like .com or .uk use letters. This extension must be at least 2 characters long, with absolutely no upper limit. Finally, we use the $sign to ensure the string ends exactly right there. Nothing else is allowed after that point. And there you have it, a powerful Python regex built specifically for reliable email validation. This perfectly validates addresses like james@example.com or bobsmith@company.co.uk. They are valid, but look what happens with an invalid input like John @ It fails instantly because the .com portion is missing. Similarly, typing just example.com fails because it lacks our required starting characters. Now, this basic regex isn't foolproof. Edge cases can slip through. For instance, a double dot before the extension might get accepted, even though it's technically invalid. But this is the perfect stepping stone to mastering regex in Python. Previously, we used this email validation regex to search for and validate user email strings. But what if you want to restrict domains to a specific type? Imagine allowing .com and .dev, but blocking .io. How do we lock that down? Take this example, james@example.com. To achieve this, let's look at how our pattern currently behaves. Right now, it accepts any character from A to Z with a minimum of 2. Watch what happens when we change that minimum to 4. The email instantly becomes invalid because it now expects 4 characters after the dot. Like .com after the dot, this extension section right here requires 4 full characters. To solve this elegantly, we can explicitly whitelist specific domains. This is a massive, real-world requirement for most corporate apps. Instead of a generic range, we want to target precise choices. So, goodbye square brackets, we're switching to round parentheses. Inside, we'll specify .com, then use the pipe symbol as an OR operator, followed by .dev. Perfect. Everything else gets locked out. Let's run this test, and boom, the email is completely valid. Now, what if we want to allow .engineering? This is a super common internal domain for tech companies. Notice it returns false right now. To fix this, we can easily add engineering as an approved choice inside our round parentheses. Just like that, the email becomes valid. However, an email using .io, for instance, remains strictly forbidden and will fail validation. Switching it to .io, since it's not on our whitelist, it gets rejected immediately. That is how you cleanly restrict to precise domains. Now, notice the $sign here. It marks the end of the string. No extra characters allowed. Let's change this back to our valid engineering email address. We're back on engineering, but what if someone appends an extra letter, like the letter F? It instantly triggers a false. Watch what happens if we remove that crucial $sign. It suddenly claims engineering F is valid. That's a huge bug. We must explicitly terminate our string, so we append that $sign. This guarantees no rogue characters can sneak past. Running it now safely rejects the email due to that extra F. Remove the F, and it works flawlessly as expected. If you leveled up your Python skills today, smash that subscribe button, drop a comment below, and let's bring Python mastery to everyone.